So part 4 of our review of our prerequisite course, inverse functions. We want to verify that one function is the inverse function of another function. We want to determine whether a function has an inverse function, develop properties of the 6 inverse trigonometric functions. So definition of an inverse function. Function g is the inverse function of the function f. When we do the composition f of g of x, we get x for each x in the domain of g. And g of f of x, when we do the reverse composition, we also get x for each x in the domain of f. The function g is denoted f to the negative 1, which is read f inverse. Reflective property of inverse functions. The graph of f contains the point AB if and only if the graph of f inverse contains the point BA. In other words, all a inverse function does is takes the output or the y value of the original function, performs algebra on it, and gets out the x value of the original function. The x's and y's switch. So we take a look at a graph of f inverse and f. Notice they are reflected across the line y equals x. The existence of an inverse function, a function has an inverse function if and only if it is 1 to 1. So it has to pass the horizontal line test as well as the vertical line test. Vertical line test is for whether it's a function. Horizontal line test is for whether it's 1 to 1, which means its inverse is also a function. So we're going to verify that one function is another. It is an inverse of another function and determine whether a function has an inverse function. So we have two functions here. For example, one, f of x equals x squared plus 1 for x greater than or equal to 0, and g of x equals the square root of x minus 1. We want to show that they're inverses of each other. So we do the composition f of g of x. So f of the square root of x minus 1, or the square root of x minus 1 quantity squared plus 1. Start simplifying, we get x minus 1 because the square and square root cancel, plus 1. The 1's cancel and we get x. So far we're on a good start. Now do the other composition, g of f of x. So equals g of x squared plus 1, which is the square root of x squared plus 1 minus 1, which is the square root of x squared. The squareds cancel and we get x. Since f of g of x equals g of f of x both equal x, then f of x and g of x are inverses of each other. You have to show both compositions. Example 2, use the graph of the function f of x equals 3 minus x over 2 in the horizontal line test to determine whether the function has an inverse. I'm going to rewrite the function a little bit here into more slope-intercept form. So divide both pieces by 2, so 3 halves minus 1 half x. Rewrite it in slope-intercept form, negative 1 half x plus 3 halves. I've got the y-intercept, which is 3 halves, and I go down 1 unit and right 2 units to get the function. So I've got the graph. Do the horizontal line test, it passes. It only hits one point, no matter where I draw that horizontal line. Guidelines for finding an inverse of a function: determine whether the function given by y equals f of x has an inverse function. Solve for x as a function of y. X equals g of y equals f inverse of y. Interchange x and y, the resulting equation y equals f inverse of x. Define the domain of f inverse as the range of f. Verify that f of f inverse of x equals x and f inverse of f of x equals x. So those are our basic guidelines. Narrow that down a little bit. Find the inverse function of f of x equals cube root of 7 plus x. Cube root function kind of looks like walk like an Egyptian. And that kind of passes the horizontal line test. So instead of writing f of x, write y. And we got two ways we can deal with this. We can deal with it as cube root of 7 plus x, or we can deal with it as a rational exponent, 7 plus x to the 1/3. Switch x and y in both cases, and then start solving for y. So how do you undo a cube root? You cube it. And undoing 1/3 power, we take it to the reciprocal power. So that also means cube it. So we get x cubed plus equals 7 plus y, x cubed equals 7 plus y. It's the same thing, just two different ways of looking at it. Then subtract 7 from both sides. We get x cubed minus 7 equals y. Doesn't matter which one we work with. And so our inverse is f inverse of x equals x cubed minus 7. Develop properties of the 6 trig functions, inverse trig functions. Definition of inverse trig function. So y equals arc sine of x if and only sine of y equals x. Its domain goes from -1 to 1, and its range goes from -pi/2 to pi/2. Arc cosine is a function if and only if cosine of y equals x. Its domain is the same as arc sine, -1 to 1. Its range goes from 0 to pi. So if we think about it, arc sine is quadrant 4 and quadrant 1, and arc cosine is quadrant 1 and quadrant 2. That's where its answers are. Arc tan is a function if and only if tangent of y equals x. Its domain is -infinity to infinity. Its range is -pi/2 to pi/2. So just like arc sine, arc tan has its range in quadrant 4 and quadrant 1. Arc cotan has a domain -infinity to infinity. Its range is 0 to pi, again quadrant 1 and quadrant 2, just like arc cosine. Arc secant, its domain is absolute value of x is greater than or equal to 1, and its range is from 0 to pi, as long as y does not equal pi/2. And arc cosecant, absolute value of absolute value of x is greater than or equal to 1. Its range goes from -pi/2 to pi/2, as long as y does not equal 0. Now, looking at arc sine, notice the pieces of it. It goes from -1 to 1, and its range -pi/2 to pi/2. That's where it hits all of its values. Arc cosine, -1 to 1 for the x values, and 0 to pi hits all of its values for y. Arc tan, or tan inverse, domain is -infinity to infinity, but it keeps between -pi/2 and pi/2 for its horizontal asymptotes. Arc cosecant has, if you notice, -infinity to -1, 1 to infinity for its x values, and then from -pi/2 to 0 and 0 to pi/2. It includes -pi/2 and pi/2, but it does not include 0. It approaches, it does not equal. Here's arc secant. Notice I'm putting these across from who the reciprocal is, arc sine and arc cosecant, arc cosine and arc secant. And then arc cotangent. It goes from -infinity to infinity for its domain and goes from 0 to pi for its y values. Looking at those properties again, if x is between -1 and 1 and y is between -pi/2 and pi/2, then sine of the arc sine of x will equal x, and arc sine of the sine of y will equal y. If if y is between -pi/2 and pi/2, then the tangent of arctan of x will equal x, and arctan of the tan of y will equal y. Basically, it's telling that they undo each other and that they're inverses. And if absolute value of x is greater than or equal to 1, and y is between 0 and pi/2, or y is between pi/2 and pi, then arc secant of x will equal x, and arc secant of y will equal y. Similar properties hold for the other inverse trig functions. Now let's take and evaluate some with these. Arc cosine of √3/2. Well, first thing I draw is the 30, 60, 90 triangle with its sides. If I have a side value of a across from 30, then across from 60 is going to be a times √3, and the hypotenuse is going to be 2a. When I look at √3/2 for cosine, that means I'd be looking at the 30 degrees because the a's would cancel out to get root 3 over 2. So that tells me, well, finish putting the things in. 60 degrees is pi over 3, 30 degrees is pi over 6, 90 degrees is pi over 2 on the triangle. And as I said, root 3 over 2, that relationship for cosine would be the 30 degrees, which is pi over 6. We usually always put these answers in terms of radians, not degrees. Cosine inverse of 0.5, that's the same as saying arc cosine of 0.5, or arc cosine of 1/2. That's looking at the other angle, because that would be a over 2a, which would be pi over 3. Arctan of 1 means I need the other triangle, 45, 45, 90. We got pi over 2 at the 90, we got pi over 4 at the 45s, and I want 1, so that means I'm looking at 45 degrees or pi over 4. Now, this last one that we've got up here, sine inverse of negative 0.919, well, first off, does it work? Well, arc sine is between negative pi over 2 and pi over 2, so yes, I have that value. I should have said it's got to be between negative 1 and 1. Negative 0.919 is a little bit bigger than negative 1, so this kind of fits. And just thinking, at 3 pi over 2, I would have negative 1. So that kind of tells me I'm probably having something that's close to 3 pi over 2. And for this, we use the calculator. First off, we make sure it's in radian mode. We type in sine inverse, or second sine is usually what it is, negative 0.919. And so no special right triangle for this one. We use calculator, have it in radian mode, and we get that it's about negative 1.1655. Develop properties of the 6 inverse trig functions. We want to solve the following. Arc sine of 3x minus 7 over 4 equals pi over 6. We want to solve it for x. First thing you do, draw a right triangle. Take the sine of both sides. Okay, so on the left side, that's going to cancel and get us 3x minus 7 over 4. Sine of pi over 6 is 1/2. Now solve for x. Multiply both sides by 4. We get 3x minus 7 equals 2. Add 7. 3x equals 9. Divide by 3. X equals 3. Next one. Draw a triangle this time. And we've got our y is going to be in there because we're looking for the tangent of y. But we're told that y equals arc cosine of 2x. So pick that angle to be y. And arc cosine means from that angle, we would have 2x over 1. 2x would be the adjacent side, 1 would be the hypotenuse. Now we find the missing side. So this is a right triangle, so Pythagorean Theorem. Hypotenuse squared, 1 squared, equals adjacent side squared, so 2x quantity squared, plus I don't know squared. 1 equals 4x squared plus I don't know, so I don't know is going to be square root of 1 minus 4x squared. Tangent of y is opposite, so that's square root of 1 minus 4x squared over adjacent, over 2x. There's our tangent of y. And that's got to be between 0 and 1/2. How do we know that? Well, plugging in let's see, plug in tangent of 0. Thinking about it, tangent of 0 is 0 over 1, so 0. And tangent of pi over 2 is undefined, but it would be between 0 and 1/2. We can talk about it later.